Okay, verifying inverses, Unit 10, Day 2. So, two functions are inverses if they reflect over each other in the line of y equals x. So, y equals x if you have your coordinate plane. Y equals x is just this line right there. So, they have to reflect over that line right there. Okay, so let's do a couple of these. So, say we're given f of x equals 3x minus 6. Well, let's first graph that line. So if you remember the y equals mx plus b, where m is the slope and b is the y-intercept, in this case, our slope is 3 and our y-intercept is negative 6. 3 can be written as 3 over 1, so I know I go up 3 over 1. So my y-intercept is negative 6. I'm going to go to negative 6. That's my first point. Now my slope is 3 over 1, so I go up 3 over 1. There's the second point. Up 3 over 1 again. There's the next point. I have 3 points there. I can just draw the line. Okay. Now I'm going to find the inverse. So I'm going to switch my x and my y's. So I have x equals 3y minus 6. Add the 6 over, so we get x plus 6 equals 3y. Divide by 3. And you get y equals x plus 6 divided by 3. I want to rewrite that so it's in the form of mx plus b. So I'm going to divide both of those by 3. And you get x over 3 plus 6 over 3, which is the same thing as 1/3 x plus 2. So now 2 is my y-intercept and the slope is 1/3. So I'm going to go up to 2, draw that point. Now my slope is 1/3, so that means I go up 1 over 3. Up 1 over 3. I can draw that line. So now I have my two lines. I just need to see if they reflect over the line y equals x. So there's that line right there. They do reflect over that line, so we have verified that they are inverses. Okay? Let's do another. So if we have x cubed plus 4. First, let's graph that. Remember, the x cubed graph looks like that. And that plus 4 moves it up 4. I'm fine on these ones if you guys don't remember exactly how these graphs look, if you put them in your calculator and you can graph them that way. You just have to be able to put that graph onto this graph over here. Okay, so I go up 4, and then there's that graph. Sorry, I had to draw that with my mouse, so it looks really crappy. Now let's find the inverse. So I have x equals y cubed plus 4. Subtract the 4 over, take the cube root. You get y equals the cube root of x minus 4. Well, the cube root function looks like that. That minus 4 moves it right 4, so I'm going to go right 4 and draw that graph. Okay, again, sorry those graphs look awful. It's because I drew it with my mouse. But then it has to reflect over the line y equals x to be inverses of each other. That does, so they do reflect, and we have verified that they are inverses graphically. Okay? Now, to verify algebraically that two functions are inverses, then f of g of x must equal x, and g of f of x must equal x also. Okay, so let's look at this one. If we have that f of x equals x minus 7 divided by 2, and g of x equals 2x plus 7, we have to verify that they're inverses. So first let's do the f of g of x, and this has to equal x. Remember, that can be written as f of g of x. So we're putting g of x into f. So let's just put that in for that x. So that's 2x plus 7 minus 7 divided by 2, which just get rid of those parentheses. 7 minus 7 is 0, so you get 2x divided by 2, which is x, which is what we wanted it to equal, so that one's good. Now we just have to check the other way, so we have to do g of f of x. So now we're going to plug in g of f of x. You can just rewrite it that way. Then plug in f of x to the g function. So that's 2 times x minus 7 divided by 2 plus 7. Those 2's cancel, and you get x minus 7 plus 7. Then those 7's will cancel, and we're left with just x, which is what we wanted. You have to get both of those so they just equal x, which they do, so those are both good. Okay, let's do one more. So if we have f of x equals x squared minus 5, This is only when x is greater than or equal to 0. This is, these can be inverses of each other only when x is greater than or equal to 0 here. So we're only looking at the right side of this graph. Okay, and then g of x is the square root of x plus 5. So I need to find f of g of x. So I'm going to plug g of x into x, or in for x and f. So I have the square root of x plus 5 squared minus 5. Well, if you square a square root, it gets rid of it, so you get x plus 5 minus 5. 5 minus 5 is just x, so we're good there. It equals x. We just have to check the other way. So then g of f of x, plug in f of x for that x and g. So I have x squared minus 5 plus 5. Minus 5 plus 5 is 0, so you just get the square root of x squared, which is x. So those both equal x, which means they are inverses of each other. Okay, on these ones, like on your homework and on the quiz that we're going to take, you have to show all of your work or you will not get credit for them. Because your work is the credit. I don't care that it equals x, I need to see all the work. Okay, remember to take the quiz. We're going to save the back of these notes for class. And I will see you tomorrow. Oops. Okay, bye.